Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to discuss about the types of arches. As a part of analysis of structures, in this particular lecture, we are going to understand about what are the various types of arches. In our previous lecture, what we understand is what is meant by arch, in which locality it gives the better results, and what kind of nature it has. These are the primary things what we understand about the arch as a part of analysis of structures. In this lecture, what are the various types of arches, how we are categorized these types, based on which property we are going to categorize, on each category how many different types are there again. These are all the things we are going to understand in this particular lecture. Here, these are the course outcomes already we discussed in our first lecture. So these are the various course outcomes which we are going to understand. So in this particular topic, that is types of arches, based on their geometry and based on their what kind of material we are using, like that we are going to categorize these types of arches. We are identify the arch type. It depends upon the geometry and materials, what kind of materials we are using. In this particular slide, explain about that based on their geometry. So it means based on their length, size, length, width, breadth. So like that, depth. So like that, according to the geometrical conditions, based on the geometrical property, we are going to understand the how many kinds of different types of arches are there. So here, based on their geometry, arches can be classified as semicircular, segmental, or pointed. According to the geometry, we are going to calculate it like this. In this, based on the number of internal hinges, they can be further classified. So that is 2-hinged arches, 3-hinged arches, fixed arches. So according to the number of hinges, if one arch has 2 internal hinges, such type is known as 2-hinged arches. Similarly, the number it is 3. Internal hinges are 3 in that particular arch. That is nothing but the 3-hinged arch. Whenever we are fixing those end conditions, such type of arches are known as fixed arches. These are further classified as a categorized, which are based on the geometry property. So in this, what we understand, 3-hinged arch, it is the statically determinate structure, and its reaction internal forces are evaluated by the static equations of equilibrium. Coming to the 2-hinged arch and fixed arch are statically indeterminate structure. Here we are using one technical terminology, that is statically determinate structure and statically indeterminate structure. The name itself tells for us something about any kind of definition. The word itself tells something for us. Here, determinate. So, how many number of equations are there in static equilibrium equation is enough to find out such type of structure is known as statically determinate structure. So in this, saying that static equilibrium equations of equilibrium or equilibrium equation are equilibrium equation. we may call equilibrium equation or equations of equilibrium. That is not satisfied to get and determine the structure. Such type of structures are known as statically indeterminate structures. So, for that indeterminate structures, two hinged arch and fixed arch are the examples. Coming to the statically determinate structures, three hinged arches are there. So here, based on their reactions and their internal forces, we are going to evaluate such type of structures are known as statically determined. Those who are not, those are nothing but the statically indeterminate structure. Here, the indeterminate reactions are determined by the method of least work or by the flexibility matrix method. For identifying these kind of indeterminate reactions, they are going to determine using some methods, that is least work or by flexibility matrix method we are using for getting the determination of those parameters. So here two hinged arch. So this is the arch, these are the two hinges, two internal hinges are there. This is nothing but two hinged arch. One more is there, that is nothing but three hinged arch. These are going to fixed arch. These are the types. Like this is the shape. Generally we are understanding like this. Two hinged arch. So hinged support is there and one more end is also. In sometimes both are in the same axis. Sometimes it may not. That is different. But for understanding, we are having two hinges and one more is within that arch. Such type is nothing but three hinged arch. Two are there, that is two hinged, and the support is fixed. Both the ends are fixed. Such type of arch is known as fixed arch. Here, we are understanding in detail about the statically determinate. So, a structure where statically determines means if it is internal forces. So, internal forces, those are nothing but movements, shear force, axial forces, and reactions. So, these are the internal forces which are in that particular structure. In any structure, internal forces are these. So, in these internal forces and those reactions, what kind of reactions, it depends upon the load. These reactions, this is nothing but they may occur because of the dead weight, dead load, or otherwise any loads which are going to introduce in that particular structure. So, we are getting some reactions can be determined using only equations of static equilibrium. So, according to that static equilibrium, within that, without needing any additional compatibility equations or any method like superposition, such type of structures is known as statically determinate. So, we are understanding whenever for understanding about the parameters, for getting the equations, for getting the determinants from particular structure, based on their internal forces, based on their reactions, according to that, based on that static equilibrium equation is enough for getting undetermined. What are the things we are going to find out? That is enough. That statical equilibrium equations are enough. Such type of structure is known as statically determinate. Here, what are the static equilibrium equations? Here we know that those are fundamental equations which we are used analyzing the statically determined structures. There was nothing but from previous slides also I am using the word that is equations of equilibrium or equilibrium equations. Those are nothing but what are the, as per the structure, what are the structure, what kind of structure it is, whether it is arch. So we are talking about arch. So the arch, how many are there? Their internal, their horizontal forces. So any number of horizontal forces are there in that particular. Those sum of the horizontal forces should be 0. That is one of the statical equilibrium equation. Similarly, vertical forces. Vertical forces. So how many vertical forces are there in that particular structure? Their sum of those vertical forces is equal to 0. And also the movements. So where there is a chance, and it depends upon the type of the support. So whatever type of the support, at the end, sum of all movements, sum of the movements must be 0. That is nothing but the statically. So this is enough for find out the equations, for find out the required parameters. So these equations are enough. Such type of structure is known as statically determinate structure. And analysis of three-hinged arch. So already we know three-hinged arch is a statically determinate structure. And also the unknowns, we will find out the unknowns using the equations of equilibrium. Equations of equilibrium is enough. Equilibrium equations are enough for getting the unknowns in this particular conditions. So here first we are going to understand the analysis of three-hinged arches. So here at supports, hinges at abutments, there will be both horizontal and vertical reactions. These can be found using the equilibrium equation. Typically, let's say the arch is supported by two hinged arches. The third is at the crown. This is nothing but the crown. Crown is nothing but the highest point of the arch in general words. So this is nothing but the crown. This is nothing but the crown. So here also one more support. So these are the two supports. Those are hinges. So that is nothing but the three-hinged arches. So whenever this is at C, here the vertical reactions and at supports A and B can be found by using the sum of vertical forces and the sum of the moments. So according to these types. So here the vertical moments we are understanding in terms of y axis we are considering. So that is equal to 0. Why? Because it is a statically, what it is? Arch. Arch is statically determinate structure. That's why we are using this equilibrium equation. So according to that, the vertical forces are to be 0. Here RA and plus RB is equal to P. Here the P is nothing but the total load. Total load on the arch. So and also the momentum with respect to A is equal to 0 and momentum with respect to B is equal to 0. This equation we are going to find out with the help of the reactions at A and reactions at B. So the horizontal reactions are due to symmetry are found, that is equal to f of x is equal to 0. According to that, we are finding the unknown parameters in these three-hinged arches using these conditions. So in this internal forces, at any section of the arch, the internal forces such as bending moment, movements, shear force, whether it is shear force or forces, whether it is shear force or axial force, whether may shear or axial forces N can be found using the principles of equilibrium. The moment at crown hinge C is 0 because hinge cannot resist movements, because it is at the crown state. Like this is the arch we consider. So here it cannot resist the movement. So that's why the moment at hinge C is 0. Hinge C is 0. Like this we are understanding. So in this, what kind of typical equations for this symmetrical load? For example, for uniformly distributed load, so entire span is L. So load is uniformly distributed like this. So uniformly distributed load for the arch. This is the arch, symmetrical arch. Here the load is distributed, that is with respect to R. So these vertical reactions RA is equal to RB is equal to WL by 2, where L is the length of the entire span, length of the overall span, our entire span. W is equal to load. Here that is uniformly distributed load. So and these are the RA and RB are the vertical reactions. Vertical reactions. Coming to the horizontal reactions. Those are HA is equal to HP is equal to WL square by 8H. Here H is the height of the arch at crown. So that is nothing but the, from here this is C, this is A, this is B, and from here to here both are in same. So that from here to here this is equal to H, height. So like this we are going to understand this symmetrical load. Whenever symmetrical load. So what happened with whether it is unsymmetrical, whether the hinged arch is it may not be the same height. So different conditions we are going to understand whenever we are studied about this particular 3 hinged arches. Here move on to the 2 hinged arch. So 2 hinged arch, it is a statically indeterminate structure. Why? Because indeterminate structure, because and also the fixed arch also. Both 2 hinged arch and fixed arch both are statically indeterminate structures, because the internal forces and reactions of the statical equilibrium is not enough for getting the unknowns. Statical equilibrium equation is not enough for getting unknowns. For getting unknowns. For getting unknowns. So here, according to this means that the internal forces and reactions in these structures cannot be determined solely using the static equilibrium equations. Additional equations, often from material compactability or deformation criteria, are required to solve for all. So statical equilibrium is not only enough, these additional methods are required for understanding the unknowns in these particular conditions. Here, the statical indeterminacy is to first degree. This means that there is one extra unknown, typically horizontal reaction. So it comes under first degree, and also typically in most of the cases one extra unknown. Not exact, not it means not one unknown. It is not exactly one unknown is enough. Extra one unknown is there. So that can be solved using the, that cannot be solved using the only equilibrium equations. So for that additional unknowns, most typically it is horizontal reaction. Typically it is horizontal reaction. Here the additional equations derived from the deformation of the structure, such as capability condition, that the horizontal displacement at both supports must be equal. So here the additional equations derived from the deformation of structure, and also here horizontal displacement at both ends must be equal. are required to solve the unknown forces. So here we are understanding in this statical indeterminacy. So here the fixed arch, a structure fixed arch is an arch where both ends are fixed. Both ends are fixed. The supports resist horizontal and vertical translations as well as rotations. In this statical indeterminacy, the fixed arch is statically indeterminate to third degree. This two-hinged arch is 1 degree. Here that is 3 degree. This is because there is 3 extra unknowns. Those are horizontal reaction, vertical reaction and movement at each support that cannot be determined using just the equilibrium equation as with the two-hinged arch. These compactability conditions related to the displacements and rotations of the structure must be used to solve for the unknowns. So within the statical indeterminacy also, different types of degrees are involved. According to that, extra unknowns we are going to identify. So if it is one unknown, 3 extra unknowns, it is depends upon the statical indeterminacy. So according to, based on that extra unknowns, what kind of method we are going to choose for getting those unknowns to solve. What kind of methods we are using to solve for those unknowns. So that is the different thing which is involved in this statical indeterminacy. The degree is important. According to that, we know the how many extra unknowns are there and what are there. So here 3 are there, that is horizontal reaction. In previously only 1, that is it may be typically horizontal reaction. Coming to the 3 degree, whether it is maybe horizontal reaction, vertical reaction and movement at each support. So these are equilibrium equation is not enough. So as with the two-hinged arch, we are going to understand what kind of equations are required. So like that we may solve for the unknowns. Here number of equations and number of unknowns. In both the cases, the number of unknowns, reactions and internal forces exceed the number of available equilibrium equations. For example, in two-hinged arch, while we have 3 equations, in any conditions, most of the conditions, those are 3 statical equilibrium equations, those are horizontal forces. The sum of the horizontal forces acting on the structure is equal to 0. The sum of the all vertical forces acting on that particular structure is equal to 0, and also the sum of the all moments. There are these 3 unknowns, but according to the 3-hinged arches, there are 4 unknowns. 2 vertical reactions, 1 horizontal reaction and 1 movement. Therefore, you need 1 additional equation, which usually comes from the geometric compactability of the structure. So, like this, we are going to understand the number of unknowns. This compactability and flexibility. The compactability conditions take into the account the deformation of the structure under load. The deformation of the structure under load, ensuring that all parts of the structure fit together as they deform. For instance, in a fixed arch, the condition that deflection at the supports must be 0 since the supports are fixed provides additional equation needed to solve the problem. So in this, equations for indeterminate structures, flexibility method, stiffness method are there. This method involves in moving to the, for these indeterminate structures, flexibility, this method involves removing enough supports to make the structure statically determined, analyzing the resulting determined structure and then applying compactability conditions to find the removed reactions. Moving to the stiffness method, this method involves writing down the equilibrium equations for the structure in terms of displacements and then solving for those displacements and the forces. So in this, we are going to understand some few terminology. Those are springing. This is the point where the arch axis meets the supporting structure, column, pier, wall or abutment. That is nothing but the springing. This is the point where the arch axis meets the supporting structure. In a simple arch, there are two springings. The springings may or may not be at the same level. And crown. This is the highest point of the curved axis of the arch. In case of symmetrical arch, with the springings at same level, they will be above the midpoint of the arc span. In an unsymmetrical arch, the crown is at unequal distances from the each support. It is symmetrical arch. It means it is at the equal distances from the each support in most of the cases. This soffit. This is the lower surface of the arch which is normally curved in this shape. In case of trussed arches, the line joining the nodes from the soffit. Rise. The vertical height of the crown above the springing is the rise of the arch. Span is nothing but the horizontal distance between the two springings is called span. In arches, till now we understand in terms of geometrical property based on that. Now, arches can be classified according to the materials used in their construction in following way. That is, brick or stone masonry arches. Whenever we are using brick or otherwise stones for constructing the arches, such type of arches is known as brick or stone masonry arches. Whenever in the RCC structure, reinforced concrete structures, we are using these kind of material, reinforced concrete, such type of arches is known as reinforced concrete arches. Steel arches, we are using steel as a material, such type of arches is known as steel arches in terms of materials used in their construction. Timber arches, we are using wood or different types of timbers available. Such type of arches is known as timber arches, or otherwise what kind of material we are using, whether it is wood, for example, wooden arches. Like that we are going to use as per the material, what kind of material we are used for getting that arches. Such type of classification is there, is this. So here the arches can be classified according to the shape of the soffit curve also. Circular or segmental, parabolic, cycloid, inverted catenary. So it depends upon the shape. We are going to classify the arches, the type of arches. And arches can also be linear arches, trussed arches. In linear arches, in which case their center lines are composed of a series of straight segments forming a curve, or trussed arches, in which case they are composed of a linear elements joined together to form a non-linear curve, trusses. So like this also we may understand, we may classify the arches, that is linear arches and trussed arches. Trussed arches. So like this. So this is the arch rib, this is the spandrel columns, this is nothing but the springing. This is nothing but the springing. This is hinges and abutment. And this is tied arch bridge, this is fixed arch bridge. So here, whenever the arch rib, this is nothing but the arch rib. This is nothing but the arch rib. This is nothing but the arch rib. These are all the hangers. And this type is nothing but the tight trophic deck. So here, these are nothing but the abutment. this is nothing but the abutment, and this is the arch rib. This is nothing but the arch rib. These are the hangers. And fixed arch bridge. We'll see the fixed arch bridge. So here, this is the traffic deck, and so this is the arch. This is the arch. This is the arch. These are spandrel columns, and this is the arch rib. Another type. This is the arch rib, and this is nothing but the springing. Like this, we are understanding the various elements which are involved in these arches. So bending moment diagram for a three-hinged arch. We know that for an arch, bending moment at any point equal to bending moment, refer the HY is refer the H moment. So refer comparison between the arc and beam. So here it varies with respect to Y. Therefore, the shape of the bending moment due to H should be the shape of the arch. Therefore, to draw the bending moment diagram for an arch, draw the bending moment for the beam. Over that, superimpose the H moment as shown in figure. So like this is the arch. We consider the symmetrical one. We consider the symmetrical arch. A and B are the supports. It is a three-hinged arch. This is the crown C and AB. This is the span length of the thing, and whenever this is W, load is acting. So here, from here to here, that is A, where the load from this side, that is the A, and this is the remaining is B. L is equal to A plus B, and from the height, this is equal to H. And here now we draw the shear force and bending moment diagram. This is positive and bending moment diagram like this. So within this thing, so this is the bending moment diagram. H, now we are going to draw the H's. So like this is positive, this is negative. Like that we are drawing the things. So here these are the some of the references we are going to understand, better understanding about this concept. So these are the things we are going to understand in these types of arches. In this, we will give the better understanding about the theoretical concept. Here some of the problems are there. In detail about the subject, this gives the better understanding. So these are the three different types of references which are available for getting the better understanding about the structural analysis. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.